Alright, so cool. So assuming everybody get through to download the software. So we first, like kind of like a dummy, just for you to understand everything. There's the first project that we will go through. So the link it in the description. So just click it, download it. And once you download it, you can just open it and it should come up and look like this. So kind of like basics of power, without going in depth into it. So this video is not to go into the numbers you're seeing really, it's just for the use of the application itself. So this is a generator. These are generators. These solid things are called buses, right? And then they have the lines that connected, the transmission lines that connected them. And these things here are just doing the loading of the line itself to see the line itself overloaded or and such. And these here are called loads. The arrows are just loads, so like your houses and the things that actually consuming power. And this is a transformer. Alright, so the transformer is a transformer. It steps, in this case, it's stepping up. Sorry, this transformer is stepping up. So if you double click it, you'll get all the information you need for the transformer itself. So we'll learn more about per unit impedance coming up, but giving you the MVA limits of the transformer, so that's really where you get all the information for the components. And the same thing for the transmission lines. If I click on it, majority of the time what you need from the transmission line is the MVA limit of it and also the impedance. So the real and the reactive parts of the line itself to get the impedance of it. Because I mean, if you're doing anything, you need to know what the impedance of it is. Because I say again, the voltage drop and everything. And really that is the main components. You have buses, you have transformers, you have generators, you have loads. As majority of what power is. You have the thing that generates any power, you have the thing that transmits any power, and you have the thing that using or consuming the power. Alright, so one thing I could tell you all about ISIS, the purpose of ISIS really is trying to understand how or the implications of how power is transmitted. Right, so basically short circuit analysis or just analysis of faults, like what could go wrong while they're transmitting the power. That's really what ICE is going to be about. How we going, what could happen, and how you as an engineer could prevent it from happening, or if it is to happen, how quickly can you resolve the fault? You know, we call it a fault. Right, so a fault is any disturbance to the system itself, right? So, and it have multiple types of faults, which you will do. But for now, the purpose of ISIS is just for you to one, the detection of the fault, clearing of the fault, and the different ways in which the fault could happen and what could happen to your system when that happens. Right, so the first thing I way to do is actually like insert a fault. Right, so to insert a fault, just right click on any of the solid lines and you go to fault, and this page will come up. It's a big page. Cool. So the first thing you do is you go across to here and you want to put the fault on the bus itself. And here you have four different types of faults which you all will do, or we will do. You'll do it in class and I'll do some questions on. So these are the four basic types of faults that could happen on a system. So the most fundamental one is a three-phase fault. This doesn't happen all the time. So basically these faults, so you can picture for now, let's say you have a three-phase generator. So your generator producing three phases, phase A, phase B, phase C, all 120 degrees spatially apart from each other, right? And they're going across in three transmission lines from the generator. So, and like we see at the end of it is a loop, keeping it simple, right? So what could happen? The three types of faults is that all three lines burst and go straight to ground. which is very impractical because majority of the time that do happen, right? So if all three of the lines burst or whatever, or three fall and all, and it just each individually go to ground, that would be a three-phase balance fault because all three phases went to ground or was faulted. The other type is a single line to ground, which most of the time is most popular. So that be just one of the phases of the generator burst or battery fallenness or something, and that singular line goes to ground. So we call it a single line to ground fault, right? The other one is a line to line. So it's basically a line burst, but instead of it going to ground, it goes and connects to another phase. So you have a line to line fault, or just a tree fall, and because the tree fall on the exposed phases, it just kind of shorts the two phases to each other. So you call a line to line fault. And this one, as the word says, basically the same thing as a single line, but instead of a single line going to ground, you have two lines going to ground. So you have a double line to ground fault. So to keep it simple, all three of the lines going to ground, one line going to ground, two lines going to ground, or no line going to ground, and it going to another line. Right? So let me just say it was a three-phase balance fault. The fault impedance, you already wouldn't check this for now, but if anything, this basically says that let's say it goes to ground, but like you say it connects to a tree. The tree can have an impedance. Remember, the word impedance means it has a real and imaginary part, right? So I would call it a R and a X. So let's say it connects to the ground through the tree. The tree has an impedance, so you call it a fault impedance, which is just a impedance to the pathway to ground. Call it a fault impedance. Normally they will just assume this to be zero, but in reality it always has a fault impedance. So basically, if you go into any company, they'll tell you to wear shoes and clothes and all these things. What this does is basically just increasing the fault impedance. So the higher the impedance of the thing that taken to ground is the least damage that will occur. The smaller the resistance or the impedance, the current will be higher, and well, you can tell what gonna happen if the current increase. You're basically dead. So if you could increase your impedance to ground by doing multiple things, it will decrease the current, hopefully to a safe level, hence protecting you or basically anything else. So that's what this is. And well, this side giving you the values of it. As I said, the per unit, we'll explain that in due course, but this video is just about the application itself, right? So for now, we just use amps to keep it simple. So when you're ready to run the fault, you just select the bus that you want the fault to happen on. So if it's bus 2, you click calculate, and it will give you the voltage of bus, well, voltage of all the buses. So when you do something in one bus, it affects or it should affect all the buses. So if a fault is to happen on one bus, meaning that one of the phases at that bus goes to ground, it will affect the current and the voltages seen at the other buses. Alright? Every action have an equal and opposite reaction. So these are the fault current that you flow. So the current that flowing to ground and will the angle fit. And well, these will be the same thing that up here, but it will be the effect at all. So basically, if bus 2 shorts the ground, the voltage will be zero, because that makes sense. Because if you short something, the voltage is normally zero, but you have a high current. And the other buses will have voltage where it will just be a little small. And the same thing if you was to put it at 4, you see 4 is zero now, because that is the one that went to ground. And the currents will be high. So that is your fault current, right? And you can do the rest for all of them, but it's really the same idea that you're trying to do. Alright. So that's how you basically do a fault really on your system itself. And basically that's really the first video. The other ones coming up will be on like editing the system itself. But just to recap everything that we did. So, well, to go back to the window, you just click here and you just click short circuits, and it will take you back to your home screen. So you have generators. In the generators, if you double click it, you will get the impedance. Well, the per unit impedance of a generator is always 1. As I said, you'll catch that in following videos, but they will give you the megawatt output of the generator itself. So here, that is important information. If you double click the transmission line itself, it will give you the impedance. In this case, the per unit impedance. And you have the loads. In this case, you don't know what the load is because it's 0, but in most cases, it will give you what the load is. And you have a transformer. Same thing, if you double click the transformer, you'll get the per unit impedance of the transformer itself. And if you had to run a fault, you right click on one of the lines. Faults, and as I said, is a bus fault. And you have 4 different types. You just click the fault, click where you want the fault to happen, and if you calculate, and it will calculate it. So how you will know what bus it happened at, the voltage will be 0, and the phase most of the time is 180. Alright, and basically that's it. So in the next video, we'll be going through what this per unit thing is, and we'll actually do a question where we actually use the per unit to calculate some stuff. Right, so if that's it, we'll talk in the next video later.